In this example, we want to find the voltage across the 3 ohm resistor, V3, and we're given the polarity which we have to use to interpret that voltage. Now, if I want to stick with this voltage polarity, I have to define the current through the 3 ohm resistor as being into the positive voltage terminal. So this is going to be my current I3. Now, if I can find the current I3, I can use Ohm's law to get the voltage V3. So let's do KCL up here and define the current through the 2 ohm resistor as being I2, positive in that direction. KCL tells us that the current entering the node must equal the current leaving the node, so I2 is just equal to 2 amps. Since the current going into an element has to be the same as the current coming out of the element, we also know that the current going this direction is 2 amps. I3 has been defined positive this direction, so if we do KCL here, and sum positive currents entering the node, 2 amps plus I3, because they're both going into the node, are equal to 0, so I3 is equal to negative 2 amps. So finally, V3 by Ohm's law is equal to I3 times 3 ohms, which is equal to negative 6 volts. Negative 2 times positive 3. So V3 is negative 6 volts, so we have a positive 6 volts with the alternate polarity. Now, this isn't the only way we can do this problem. Let's try something else. Suppose we still do KCL up here, but we say the sum of the currents entering or leaving, and we can very obviously write that this is 2 amps. So this is still 2 amps. Now, if we define positive current going this direction, currents entering have to equal currents leaving, so this is 2 amps. However, if we're going to use Ohm's law, we still need to define voltages and currents such that positive current is entering the positive voltage terminal. So now we have to define the voltage across the 3 ohm resistor as being, say, V sub x. Now by Ohm's law, V sub x is equal to 2 amps times 3 ohms, which is equal to 6 volts. V sub x, however, has the opposite polarity as V3. So in order to get V3, we have to switch the sign on V sub x. And we get an answer that's consistent with this one.